Hi, we have AP Physics 1 past paper 2025. We are discussing free response question section. In this section, question number 1 carry the 10 points. A student has a cart of mass MC and a block of the mass 1 by 5 of the MC, 1/5 part of the MC, as shown in a fig. At the time t0, cart is moving to the right across the horizontal surface with the constant speed. Constant speed means there is no horizontal force acting on it. Acceleration of the system is cart is 0. So that's why we consider that the external force is acting on this is equal to 0. And the student releases the block from the rest. Okay. Now at time t is equal to t1, the block collides with and stick. Stick means that's the inelastic collision to the top of the card. The block doesn't slide on a card, means there is no horizontal force still. At t is equal to t2, the block system card system continue to move with again constant velocity. Again constant velocity means again there is no still external force acting on a system. So that's the reason. Now, question A, on the axis shown, the fig 2, sketch a graph of the magnitude px of the x component of the momentum of the block chord system as a function of time from t0 to t greater than t2. Okay, this is the axis given we have. Now we have considered as ready in the question, t is equal to 0 to t1, cart move with the constant speed. So block is in air, there is no horizontal external force acting on a system, so x component is constant. So we have drawn the x component from t0 to t1 is equal to as such as a horizontal value. So during the time t is equal to t1, the block hits the cart. Forces exerted on each other are internal forces. There is no external force. So horizontal force like friction or from the ground, the x component of the system remains constant. Mean again it is the value is constant from at the time of collision. So after the T2, the system moves at the new constant speed. Px still remains the same value. So that's the greater than T2 value is still remaining the same. Now drive the expression from the final speed of the block chord system after the time t is equal to t2 in term of mc, vc and physical constant as appropriate. Begin with your derivation by writing the fundamental principle of an equation from the reference information. Okay. Now, in the absence of external force, total momentum of the horizontal system remains constant. This is the law of conservation of angular momentum, as it is a fundamental principle, or there is the momentum of the system remains constant if there is no external force. After the time collision t is equal to t2, blocks stick perfectly inelastic, no sliding, so move together with the common speed vf. So we have to write the final momentum should be equal to initial momentum. So initially there are two different objects, cart and the block. After they stick, so there is a combined mass is taken. Now initially the cart is moving, block is at the rest, so that's why we have placed the velocity equal to 0. So and finally they are combined, so their total mass is taken, and finally their combined velocity is represented by the vf. Now after that this whole factor is disappear from here, mc is going to be cancelled, so final velocity is equal to 5 by 6 into vc. So that's the answer of part 2. Now the drive the expression for the change in kinetic energy of the block chord system from T0 to T2 in term of MC, Vc and physical constant as appropriate. Bring your derivation writing the fundamental principle or equation from the reference of information. So change in kinetic energy as delta K is equal to final kinetic energy minus initial kinetic energy. This is the equation from which we have to refer. So final as asked, change in kinetic energy, change is always final minus initial. So initial system there is two different objects, cart and the block. Again 1 by 2 mv square for the cart, 1 by 2 mv square for the block. Block is initially at the rest, so their initial kinetic energy is going to be 0. So only kinetic energy initially 1 by 2 mc vc square. Again final kinetic energy, now the both system are stick, both objects are stick, cart and the block. Their combined mass is taken. Final velocity is Vf square. We have calculated their combined final velocity. So we can place the Vf value is here. Now their total value is equal to 1 by 2 5 by 6 mc vc square. After simplifying the, I skip the sum algebra here. So that's the final kinetic energy. Now we have to find the change, final minus initial. So that's the answer is minus 1 by 2 mc vc square is here. Okay. Now next part of the question, consider the case where new block is dropped and collide on the top of the cart. New block slide along the cart during the collision but doesn't slide off the cart. The time interval from the new block collide with the cart and move together is delta t. During the delta t, there is a frictional force between the new block and the cart. Indicate whether the x component of the momentum of new block cart system increase, decrease, or remains constant, or we have to justify the our response. Now answer is it should remain constant. Justification: during the time delta t, frictional force between the block and the cart internal system. There is no external horizontal force acting on a system. Therefore, x component of the momentum is conserved and remain constant. Momentum change only when external force is applied to the system. So that's the representing that when external force is there, there is a change in momentum. So that's reason that's the friction act as an internal force between the system. So that's reason the momentum of the system remains constant. That's the answer. If you have any query, kindly ask in the comments. If you like the content, kindly subscribe and share it with your friends. Okay, take care.